Alright, so this is going to be a quick tutorial on what density is. So what is density? Alright, well, a definition you might see like on the internet or in the dictionary, it would say mass per unit volume. Okay, the units for density that are mostly used in this class anyway are going to be grams divided by milliliters. Okay, because grams is the unit of mass, per is this division right here, and then it's the unit of volume that we're going to use mostly, which is milliliters. So grams per milliliters. If you remember from the lab though, cubic centimeters is the same as milliliters. So sometimes you'll see it say grams per cubic centimeters. So if you see that somewhere, don't get that tricked up. Just know that 1 cubic centimeter is equal to 1 milliliter. All right. Another definition for density is the amount of matter in a certain space. Okay, so if you have a lot of matter in a smaller space, that would be really, really dense. Compared to if you have a small amount of matter and it's spread out a lot, that would be something that has very low density. Or you can think about density mathematically, which is just D equals M. So D is density equals M. This small m is mass divided by the volume. So mass per unit volume. Okay, and make sure to have the right units in that when you're using this equation. All right, so here's some ideas about density. Different substances usually have different densities, and this could be used to identify certain substances. So say you had a sample of a metal or a gas or really any matter for that matter, you could actually figure out or maybe at least get an idea of what that substance is made of based on its density. So for example, if I had a metal and I was like, oh, what's this metal? I really want to know what it is. You can figure out the density by just taking the mass of that metal, dividing it by the volume of it and get the density, and then looking up online certain metals that have that density, that are closer to that density, and kind of give you an idea of what that metal might be. That's a really important property of density. Another idea, if a substance has less density than the fluid that directly surrounds it, now by fluid I mean liquid or gas. Okay, solids are not fluids, they don't flow. If a substance has less density than the fluid that directly surrounds it, then that substance can float. And this is assuming that the substance does not dissolve or react with the fluid surrounding it. So an example is oil and water. Oil and water do not mix. So because of that, it doesn't dissolve, doesn't mix, doesn't dissolve. So because of that, the oil will actually, because it's less dense, it will float on top of the water. You've probably seen this example before, but I just have this picture to kind of show you. It works the same with any other substance as well. I just like to use this oil and water as an example. Okay. Some of the problems on your problem set involve solving for, using the density equation, but you're solving for the other variables. Solving for D, the density, that's probably the simplest one, obviously, because you're just taking the mass and dividing it by the volume. But if you're going to find the mass of a sample, if you know its density and its volume, well, all you'd have to do is solve for M in this equation at the top. And that's basically what I did right here. So I wanted to solve for M, so I got rid of this V, so it's divided by V. The opposite of divide is multiply, so I multiplied both sides by V. It canceled out the V right here, and you end up D times V equals M. So this is how you solve for the mass in a density problem. Solving for volume is a little bit trickier, so I'm just actually going to use what I solved for the mass one right here to solve for V. So I have dV equals M. Well, I want to get rid of this D, so I divide both sides by D. It cancels this D out right here, and you end up with V equals M over D, because I had to divide both sides by D. So divide D on this side, it cancels it out. Divide D at this side, you get mass over density, which is what we have right here. So if you have any questions on any of this or need any help, please let me know.